Hey everyone, now we are going to see about a interesting topic. This classical free electron theory. So let's recall. So this classical free electron theory of metals was proposed by Drude in the year 1900 and to explain the electrical conduction in metals. And this theory was further extended by Lawrence in the year 1909. And we know that the atoms consist of a central nucleus with positively charged protons and neutral charged neutrons, and electrons are revolving around the nucleus. This is a general thing we know. And the electrons in the inner shell are called core electrons, and the outermost orbit electrons are called valence electrons. So what are the topics now we are going to discuss? A classical theory of metals, then postulates of classical free electron theory, and the importance of classical theory. So what is the use of understanding this free electron theory of metals? Because its applications are vast. So they are used in electrical conductivity, thermal conductivity, material selection for electronics, optical properties, thermoelectric effects, then foundation for advanced theories, then predicts mechanical properties, then material characterization. So these are all their applications. So we should know about uh, free electron theory. So what are the postulates? They have a 10 main postulates, and these postulates now we are going to see. So presence of free electrons. Metals contain a large number of free electrons, and these free electrons are responsible for conducting electricity. So metals can contain large number of free electrons that can move throughout the material because these electrons are free electrons. They are not bounded by the nucleus. Then positive ions are fixed. Here positive ions are which is inside the nucleus, that is protons. Protons are fixed one. The positive ions remain fixed at their respective position in the crystal lattice. And random motion of electrons. The free electrons move randomly in all directions inside the metal, and electrons behave like a ideal gases. So what is that? The free electrons are assumed to behave approximately like a nucleus of an ideal gas, and straight line motion between collisions. Electrons move in a straight path between two successive, that means next collisions. And the collisions are instantaneous and random collisions. This collision happen instantly and random. First time it hit on the line, then it's towards it angle. The collision angle is different, randomly it differ. So next is relaxation time. The average time between two successive collision is called relaxation time, and it is denoted by the letter tau. Next is drift velocity. What is the drift velocity? See, when an external electric field is applied, the electrons acquire a small average velocity called drift velocity. Simply you keep this in mind. That means electrons move with the velocity. So that velocity is called drift velocity. So negligible electron interaction. So interaction between the electrons is neglected in the classical free electron model, and resistance is due to collisions. Electrical resistance arises because the motion of electrons is interrupted by collision with ions, impurities, and lattice defects. In free electron theory, some key ideas are I'm going to give it now. So free electrons as a charge carriers. Yes, the electrons are negatively charged particle, so they are carrying negative charges. Electron movement. Electrons move randomly in all directions, and electric field causes a small net motion opposite to the electric field. Next is pollution. So electrons collide randomly with ions, impurities, and defects with charges their direction of motion. Next, drift velocity. An electric field exerts a force on electrons. After many collisions, electrons acquire a small average velocity. That velocity is called drift velocity, and it is opposite to the electric field. That means applied field. The, and the force of this electron is F vector is equal to minus E into capital E vector. So here E is the charge of electron and capital E is the electric field, and the drift velocity expression is Vd is equal to EE, that means charge of electron into electric field into tau. What is tau? Tau is, what is tau? Tau is the time. Next m, mass of the electron. Next is straight line motion between the collisions. Electrons move in a straight line path between the two successive collisions. Collisions are instantaneous and random collisions. Electrons collide randomly with the positive ions, impurities, and a defect in the lattice. Relaxation time. The average time between two successive collisions is called relaxation time. Yes, let's recall. So what we discussed now in classical free electron theory assumptions, electrons move freely in the metal, and these free electrons are responsible for conducting electricity, and the collision occur randomly and there is no proper interaction. Next is the success of this theory is it explains Ohm's law. What is Ohm's law? V is equal to I R, and the qualitative idea of conductivity. And the failure of this classical free electron theory is no quantum concept. Quantum deals with the microparticles, so that concept is not explained properly in here. So wrong heat capacities, temperature dependence is wrong and cannot explain the Fermi level. And electrical conductivity, there are three formulas here we have. Formulas, sigma is equal, that means electrical conductivity is equal to N into E square tau by M, and the factor electrical conductivity depends on the density of electrons and charge of the electrons, and the applications of this electrical conductivity is metal wires and circuit designs. Applications, it is used in electrical conductors, electrical wiring, then electronic, all electronic devices have a circuits, and the circuit is used in this concept only. Next is metallic alloys, it's a ball bearing one, then heat conduction, then electric power transmission. So curiosity challenge. If electrons are always moving randomly inside the metal, why does current flow in one direction when the battery is connected? When the battery is connected, what happened? The electrons are initially moving in a random direction. When the battery is connected, all the electrons are moving in a one particular direction. So the current is passing through the metal. If electrons collide with atoms, why can metals still conduct electricity? Can you guess this answer? Why does a copper wire become more resistive when its temperature increases? Then what would happen to electrical conduction if electrons never collide with anything? So guess this answer. Reference given for this topic. Yes, thank you.